Hey there, it is Zeb again. We're back. In this video, I plan to do the second 15 problems from the Power Rule Practice worksheet. If for whatever reason the video runs too much longer than the other one, over 20 couple minutes or something, I may break it up into two videos instead of one just to keep my file sizes down. So let's jump right into it. We left off with problem number 16. Problem 16 says that f of x is equal to x minus 1 over x. Now understand that this is the same as x minus x to the minus 1. These exponent rules are really important because they allow us to take things that otherwise might not look like a polynomial and turn it into one. So we can take the derivative of this. This is f prime of x, that's our derivative, is equal to 1 minus, now this is going to be negative 1x to the negative 1 minus 1, which is of course just 1 plus x to the minus 2 power. So that's our derivative for problem 16, 1 plus x to the minus 2. For problem 17, we have f of x equals 4x to the 5/2 power. Now there's nothing really complicated here, right? 4x to the 5/2, so f prime of x is just equal to 4 times 5/2, x to the 5/2 minus 1. Of course, minus 1 is just minus 2/2. So that makes it a little easier to see what this should be. So 4 times 5/2 is 20/2, which is of course just 10. So this is 10x now to the 5/2 minus 2/2, or the 3/2 power. So 10x to the 3/2, that is our derivative for problem number 17. For problem number 18, this one should be pretty obvious, I hope. At this point, if you've watched the first video anyway, f of x is equal to 1 minus 5, which is of course equal to negative 4. What is the rate of change of negative 4? Well, of course, the rate of change of a constant term is always 0. So our derivative, f prime of x, is equal to 0. So let's move these up out of the way. So, moving on, problem number 19. Okay, so I had to take a quick break there to erase something, but it didn't completely erase. So, technical difficulties, chalk that up to inexperience. Anyway, so f of x is equal to 1/3 x, right? Or 1 over 3x is how we should say that. Of course, we can rewrite this as 1/3 times x to the minus 1. So those are the same thing. Now we can take the derivative of that using the power rule. So this is f prime of x is equal to negative 1 times 1/3 x to the minus 1 minus 1, which is equal to negative 1/3 x to the minus 2. So there you have it. Negative 1/3 x to the minus 2 power is the derivative of 1 over 3x. Problem number 20. For problem 20, we have that f of x equals x squared over 2 minus 3x. So this one is not that difficult, right? Let's just rewrite it so that we see that x squared over 2 is really just 1/2 x squared minus 3x. Now we can take the derivative, as we've always done. F prime of x is equal to, so now we've got 2 times 1/2 x to the 2 minus 1 minus, and we know that the derivative here is 3. So the 2 and the 1/2, they multiply to become 1. So we're just left with x to the 1, which is, of course, x minus 3. So there's our derivative for problem number 20. It's just x minus 3. So let's move this up out of the way. Now, problem 21. We have f of x is equal to 5 squared. Don't let this confuse you, right? There's nothing going on here. This is just equal to, of course, 5 times 5, which is 25. What is the rate of change of 25? Well, of course, that's 0. So f prime of x, there is no x, right? So f prime of x is going to be equal to 0. This thing does not change as x changes. It is always 25. Problem number 22. Problem 22, we have that f of x is equal to x squared plus 1 squared. The easiest thing to do here is to just multiply this out. So this is equal to x squared plus 1 times x squared plus 1. When we multiply this out, we get x squared times x squared. That becomes x to the 4th. Plus, we get 1 times x squared. So that's x squared. Then we get another 1 times another x squared plus x squared. And then at the end, we get the 1 times the 1. So that's how we factored this out, right? We did the first terms. Then we did the inside terms. Then we did the outside terms. And then we did the last terms, right? So that's what we got. We got x to the 4 plus x squared plus 1, which we can simplify as x to the 4th plus 2x squared plus 1. Now we know what happens to this 1 when we take the derivative. That's going to go away. So we get f prime of x is equal to 4 times x to the 3rd plus 4 times x now to the 1, which is just 4x. So there we have it. That is our derivative for problem number 22. Moving on. Problem 23. So for 23, we have that f of x is x to the 1,000. Nothing new here. F prime of x, applying the power rule, is 1,000 x to the 1,000 minus 1, which is 999. Problem 24 is very similar. For problem 24, f of x is equal to 1 over x to the 1,000. Now, of course, again, this is where those exponent rules come in handy and worth knowing, and the rules about fractions, that this is simply equal to x to the minus 1,000. Right, so that's all that is that's x to the minus 1,000. We can take the derivative of that using the power rule. F prime of x then is going to be equal to minus 1,000, we bring the exponent down, times x raised to the 1,000 minus 1, which is, of course, negative 1,000 x to the minus 1,000 1 power. So you can see how two similar looking things here in problem 23, x to the 1,000, has a totally different looking derivative than 1 over x to the 1,000, right? The derivative here is a totally different looking thing than we have in the other problem. So there's 23 and 24. Moving on. Problem number 25. So for 25, let me change back to white. For problem 25, we have f of x is equal to x squared over the natural log of 2. Now, the natural log of 2 is simply a constant term, right? So anytime you see that, think about how you can rewrite things. One way to do this is to recognize that this is simply equal to 1 over the natural log of 2 times x squared. So we can take the derivative of this because we're just going to treat this as if it's some number that's being multiplied by x squared, because that is all it is. So we've got f prime of x is going to be equal to our 2 times this 1 over the natural log of 2 times x to the 1. So this is equal to 2 over the natural log of 2, right? This 2 over the natural log of 2, that's what we get when we multiply this and this term, now times x. Right. So of course you could write it this way, that this is 2x over the natural log of 2. So that's one way that you could write that. Okay, moving on, problem number 26. We are making good progress in this video, better than I thought. So 26, we have that f of x is equal to the square root of 3x. Now this one is possibly the most difficult one that we have seen so far. And it's not hard, right? It's just you've got to remember the rules of square root. So the square root of 3x, in case you've forgotten, is equal to the square root of 3 times the square root of x. All right? So the square root of 3x is the square root of 3 times the square root of x, which is, of course, equal to 3 to the 1/2 power times x to the 1/2 power. All right, so that's what we've got there. So we've got 3 to the 1/2 power times x to the 1/2 power. Or, in this case, it may actually be easier. It's kind of rare that it would be easier to think about it this way, but I think it might be easier to think of this as being the square root of 3 times x to the 1/2. So that way we don't have that exponent there confusing us, that 1/2 after the 3. So this way it's easier to treat square root of 3 as kind of one thing. It's exactly the same, but to me I think this looks easier to know what to do with it. So f prime of x, we can take the derivative here. It's just going to be 1/2 times the square root of 3 times x to the 1/2 minus 1, which will be the negative 1/2. Now you could stop here, but that would be a little on the ugly side to leave it like this. So what you could do, the way that I wound up writing this, was that this is equal to the square root of 3. Whoa, what happened there? Okay, so the square root of 3. My palm likes to change the size of the video and move it around just to keep it exciting for you. So the square root of 3 divided by 2 times the square root of x. So that's exactly the same thing. Again, it's not something to sweat too much. All right, don't worry about writing how you should write it necessarily, but that is one way that you can do it. All right, so moving on. Problem number 27. Problem 27, again, this one I think should be pretty easy. Square root of 7. This is some number, right? This is a constant term. Constant terms, the derivative of them is 0 because they don't change. So we know f prime of x is 0. Whoops, problem number 28. For 28, we have that f of x is equal to x squared minus 1 over x. All right, so one way that we could rewrite this, if we wanted to, there's several ways that we can do this, but we can recognize that this is simply equal to x squared minus 1 times x to the minus 1. Right? That is exactly the same thing. And then when we multiply this out, we get, so x squared times x to the minus 1 is just going to be, because we add and subtract the exponents. When we multiply, we add the exponents. When we divide, we subtract them. So it's going to be x, and then we've got now this 2 plus this negative 1. So that just becomes x to the 1. And now we've got this negative 1 times x to the negative 1. That's just going to be x to the negative 1. So there we go. We can easily take the derivative of this. F prime of x is equal to 1x to the 1 minus 1 minus, now we've got negative 1x to the negative 1 minus 1. So just simplifying this out, we see that this is x to the 0 minus, and we've got a negative here, so we're minusing a negative. So this becomes plus x to the minus 2. So this then is equal to x to the 0. Anything raised to 0 power is 1. Now we've got plus x to the minus 2. So there you have it. That's 28. Number 29. For 29, we have that f of x is equal to, 8 over square root of x minus 3x. So again, just understanding the rules of fractions, the rules of square roots, and the rules of exponents, we can easily write this into something that looks familiar to us. This is just 8 times x to the minus 1/2 power. Right? Anytime you see something that's square rooted, that's the 1/2. And if the square root is in the denominator, then that's going to be to the negative 1/2 power. So we have 8x to the negative 1/2 minus 3x. So taking the derivative, we get f prime of x is equal to, so now 8 times negative 1/2, that's negative 4x to the minus 3/2, because we've got to subtract 1 away from that. So we get negative 4x to the minus 3/2, and of course the derivative of negative 3x is just negative 3. So there's our derivative for 29. And for problem 30, it's the last one. And we were just starting to have fun. So f of x is equal to, here we have 7x plus 3x squared divided by 5 times root x. All right, so there's several ways that we can do this. One way to do it is just to break this numerator into 2 parts, or to break this entire fraction really into 2 parts. So we can rewrite this as 7x over 5 root x plus 3x squared over 5 root x. Right? Those two are exactly the same thing. Given that, we could write it this way with that 3-bar equal sign if we wanted to, because they are exactly the same thing. Then when we start breaking this down, we see that this is really also equivalent to 7/5 times x over the square root of x plus 3/5 times x squared over square root of x. All right. Now I'm doing way more steps here than what are necessary, but it's just so much fun, so that's why I'm doing it. So now we're getting somewhere, but we need to simplify this term and this term. So remembering your rules of exponents and division with fractions is really important. This is equal to 7/5. Now this is times x to the 1 over x to the 1/2. And anytime you have a fraction with exponents, you subtract. All right, so x to the 1 over x to the 1/2 is simply going to be x to the minus 1/2. So we have x to the minus 1/2 here. So this is just x to the minus 1/2. Yep, that does not look like a half, but that's what it is. X to the minus 1/2 is what this becomes. Now this term is equal to x squared over x to the 1/2. So this is going to be x to the 3/2. Right? So again, I'm showing more steps here than are really necessary. So let me move this up. So rewriting what we've got one last time. So all of this was equivalent to 7/5 x to the minus 1/2 Hang on a second. What did I lose? So I said this was, I made a mistake here. So ignore what I said right here. This is not x to the minus 1/2 because we have x to the 1, then we're subtracting from 1/2. So this is actually x to the 1/2. I was really just checking to make sure you were paying attention there. And hopefully you all caught me on that and commented at that point in the video saying how wrong I was. So this is 7/5 times x to the 1/2 plus, now we've got, and I do feel confident on this second one, we have 3/5 times x, whoops, that was not good, 3/5 times x to the 3/2. All right, we finally have something that looks like a polynomial that we are used to, even though we've got these fractions. But our derivative here, f prime of x, is simply 1/2 times 7/5. All right, of course, 1/2 times 7/5 is just 7/10. So we've got 7/10 times x. Now this is 1/2 raised to the 1/2 minus 1. So this is going to be to the minus 1/2. That's where that minus sign comes in. Plus, now we've got 3/2 times 3/5. So essentially 1.5 times 3/5. And if you want to think about the math, that's fine. I'll go ahead and tell you that is 9/10. Right, so 0.9 is what you get if you multiply 3/5 by 3/2. So this is 9/10 times x to the 3/2 minus 1, which is, of course, just the 1/2. So there we have it. We have done all 30 derivatives from the practice worksheet. If you have any questions on this, please don't hesitate to contact me. Send me an email or talk to me in class. I'll be more than happy to sit down and work through these with you. Thank you very much, and we'll see you next time.